Could this be the ideal location for a moon base? Did you know that there are over 200 trenches on the moon that could be used as future lunar bases? These moon pits fit some conditions for human colonies, but what causes these lunar pits to form? How deep do they go? How would the lunar bases that could be erected on them look like? Come find out with us. The formation of pits on the moon is a complex process that is still not fully understood. The pits are thought to have formed as a result of a combination of volcanic and tectonic events. The most widely recognized idea holds that these were caused by volcanic activity on the moon millions of years ago. The moon was a geologically active body during this time, with a lot of volcanic activity on the lunar surface. Some of these volcanoes were big enough to create impact craters. Volcanic activity waned over time, and the cavities formed by the volcanoes cooled and contracted, resulting in pits in the moon. This argument gains support when we compare the wells on the moon to those formed by volcanic eruptions on Earth. According to Arizona State University scientist Robert Wagner, the pits could occur when a cave ceiling falls, possibly as a result of vibrations caused by a nearby meteorite impact. However, there is little evidence to suggest a specific reason. The trenches could be formed as molten rock flows beneath the lunar surface. On Earth, lava tubes emerge when magma flows beneath a formed crust and drains away. The same thing might happen on the moon, particularly in a large impact crater, the interior of which can take hundreds of thousands of years to cool. After an impact crater occurs, the sides collapse due to lunar gravity, forcing up the crater floor and possibly allowing magma to flow beneath the surface, resulting in the moon's pits. Exploring impact melt wells would reveal the nature of the pits that form. They are also most likely the result of melt flow into the pond caused by the raising of the upper layer after the surface has frozen. To date, the team has discovered more than 200 pits spread across the melt ponds of 29 craters, all of which are geologically young Copernican craters less than 1 billion years old, 8 wells on the Lunar Maria, 3 of which were previously known from images taken by the Japanese Kaguya orbiter, and 2 cuts on high ground. The similarities between the pits on the moon and those on Earth caused by volcanic eruptions are enormous, which is why many scientists believe that within these wells could be vast networks of interconnecting underground tunnels. However, no structure with these characteristics has been discovered thus far. The size, shape, and depth of pits on the moon can vary. Some wells have diameters of only a few meters, while others might span many kilometers. The depth of the wells varies as well, with some reaching depths of several hundred meters. Images from the Japanese Kaguya spacecraft were used to identify 3 of them. Hundreds more were discovered later with the use of a new computer system that automatically analyzes thousands of high-resolution photographs of the lunar surface captured by the spacecraft's narrow-angle camera, NAC. Features of pits on the moon. Pits in the moon have various distinguishing characteristics that make them appealing to scientists and space research experts. For starters, the pits provide natural protection from radiation and severe temperatures on the lunar surface. As a result, astronauts may live and operate in the pits with reduced exposure to radiation and high temperatures, making them potentially viable as lunar bases. Another intriguing aspect of the pits is that they can hold water and ice. Some pits have been discovered to have substantially lower temperatures than the surrounding lunar surface, implying that they may contain water ice. Water is a valuable resource in space travel since it can be utilized to produce oxygen as well as a source of hydrogen for propulsion. Furthermore, pits in the moon may provide important information about the moon's history and creation. Scientists can examine the materials found in the pits to understand more about the moon's volcanic and tectonic activity and how it has evolved. Return to the moon, but this time for good. Since humans first set foot on the moon more than 45 years ago, scientists have been investigating the potential of building a lunar base where humans could travel to the moon and dwell eternally. However, there are some problems that could be overcome if we use pits on the moon as subsurface bases. This crater was discovered recently in the Mare Tranquillitatis, which is famous for being the landing location of the Apollo 11 lunar module. This crater is 400 meters, 1,312 feet, wide. The crater has a flat surface at the bottom, and the roof protrudes from the sides, indicating that it has a vast covered area that is not visible from space, according to this image collected by the Lunar Reconnaissance Orbiter. This is critical for the future of lunar expeditions because the temperature within this type of hole might be as low as 17 degrees Celsius. Remember that the moon is extremely inhospitable, with temperatures ranging from -173 degrees Celsius to 127 degrees Celsius and persistent exposure to solar and cosmic radiation. The surface of the moon is also covered in fine dust, which can harm spacesuits and machinery. Furthermore, because the moon lacks an atmosphere, there is no protection against high-energy particles that can penetrate the surface. Many of these issues could be addressed by constructing subsurface lunar bases in these craters. Because the bases would be below the surface, they would be safe from radiation and severe temperatures, as well as meteorite hits and solar storms. Furthermore, the construction of subsurface bases may allow the utilization of local materials for construction, such as lunar regolith, moon dust, minimizing the number of components that must be carried from Earth. However, constructing subsurface bases on the moon is complicated, and various technical hurdles must be overcome. The technical difficulties of constructing subsurface bases on the moon. The main technical challenge of building underground bases in lunar craters is the regolith cover that covers the entire lunar surface. Most likely, the regolith is concentrated in greater quantities in the craters, accumulating several meters thick, which means that any excavation must begin with the removal of this layer. One alternative is to use robotic excavation devices to accomplish the digging, which poses its own set of issues. Excavation machines must be tough enough to live in the lunar environment and built to operate in low gravity and harsh temperatures. Furthermore, the devices must be able to carry excavated material from the underground base without polluting the air. Another problem is supplying power to the underground base. On the lunar surface, solar power is a possible alternative, however, sunlight only reaches particular locations in craters. The usage of nuclear reactors is a straightforward solution. However, this raises security and transportation issues. Possibly the best alternative would be to place solar panels in regions most exposed to the sun's rays. Building subsurface bases on the moon involves building and logistics issues as well. This necessitates a large number of components, ranging from machinery and equipment to supplies and nourishment for the workers. These materials would have to be brought from Earth, which would be expensive and time-consuming. Communication will be another issue for astronauts. A base inside a crater would not allow radio signals to enter or depart in many directions, just upwards, which would be an issue because a geostationary satellite would have to be positioned first, always pointing to the base, so it could communicate all the time. Despite the technological and logistical hurdles, establishing subterranean bases in moon craters could provide numerous benefits. Shielding from radiation and severe temperatures, for example, would allow for more complicated and long-term scientific studies on the moon. Furthermore, the subsurface bases might be used as material and supply storage depots, minimizing the quantity of material that must be transferred from Earth. Using the pits as lunar bases. Pits as lunar bases have both advantages and downsides. One of the most significant benefits is the natural protection they provide against radiation and harsh temperatures. Another benefit is that the holes could contain water ice, which would be a vital resource for space travel. The water may be utilized to generate oxygen and as a source of hydrogen for propulsion, allowing people to spend longer amounts of time on the moon and carry out more ambitious missions. However, there are several drawbacks to using the pits as moon bases. For starters, the pits can be difficult to enter and explore. The majority of holes are several kilometers deep, making investigation and material transfer difficult. Furthermore, the trenches can be hazardous to astronauts. Hidden risks, like as fissures or weak spots in the ground, could jeopardize the safety of astronauts operating in the trenches. Furthermore, the absence of sunshine in the pits may offer additional problems to the astronauts' exploration and labor. Despite these disadvantages, moon pits remain an appealing choice for moon bases. Additional research and studies are being conducted to investigate how the pits can be used for space exploration in a safe and practical manner. Finally, researching lunar pits is critical for the future of space exploration and the prospective establishment of lunar outposts. Despite the difficulties in discovering and utilizing pits, their potential is fascinating and encouraging. Ongoing research and study of pits on the moon will aid us in better understanding their genesis, properties, and potential applications in space exploration. We are one step closer to finding and exploiting the entire potential of the moon thanks to our effort and dedication.